Hello, my dear friends. Hope you are doing well. Many of you have done with your J, and for few of you, it was today and tomorrow also. Then J is something which you are done with. You need to concentrate completely on BITSAT. So, in this session, my dear friends, I want to take a topic which many of the students feel quite difficult and quite important topic of topic from kinematics. It's a projectile motion. Definitely, you are going to get at least one question from projectile motion. It is quite important. So I have decided to take this topic for you. So it's just a conceptual topic I'm going to take you. And what type of questions are asked, I'm going to tell in between also. So let me share my screen and start this session for you. Hope it would be very much helpful for you when you prepare for BITSAT. So here we go, my dear friend, projectile motion. Now, conceptual clarity is very important when we talk about projectile motion. Guys, many of the students feel projectile motion is always like, it's always like, you for example, in a football field, you're kicking a ball. So that's called projectile motion. And all the motions which are following that parabolic path, it's going to be called projectile motion, but it's not always that, my dear friends. We need to understand what actually is projectile motion. So, projectile motion is actually motion under gravity. Motion under action of gravity. Motion under action of gravity. If the motion is not under the action of gravity, then it will not be called projectile motion. For example, if a bird is flying like this. A bird started flying from the ground, and it is flying like this. Is a bird. It feels like it is following a parabolic path. Okay. Someone who feels that this is this type of motion which follows the parabolic path, it's called projectile motion. But my dear friend, do you think this will be called projectile motion? Well, no, it is not projectile motion because this is a motion by bird, and it is not under the action of gravity, because bird is applying power, and it's not completely under action of gravity, so it's not projectile motion. How about someone is standing on the top of building? A person is standing on the top of a building and dropping a ball. Is dropping a ball projectile motion? Do you think that this is a projectile motion? You are dropping a ball. Well, this motion doesn't feel like a parabolic, following a parabolic path. But is it projectile motion? When such type of questions are asked, that which one of these is projectile motion, which one of this is not projectile motion. So, my dear friend, if you drop a ball, a person is dropping a ball standing on the top of building, this is projectile motion. Yes, because this motion is happening under the action of gravity. So it doesn't matter whether the path is going to be parabolic or not. If it is under action of gravity, that's going to be called projectile motion. Hope this concept is clear to you. I believe that. Right? Now, my dear friends, moving ahead, let's talk about some of the components. Very quickly, we will be, brush up the basics. For example, someone is in the football field and kicking a ball. Someone is kicking a ball and a ball is kicked. A ball is kicked, ball goes like this. So this point from where it is kicked, it's called point of projection. It's called point of projection, right? The angle which this ball is going to make with the horizontal, it's called angle of inclination, right, my dear friends? And this ball which you have kicked, which is doing the motion, this ball is called projectile. This ball is called projectile, right? This ball is going to achieve some maximum height. At one point, it's going to attain maximum height. That's called H max. It's called H max, height maximum. Right, my dear friends? The horizontal distance it is going to travel, it's going to be called range. Horizontal range. This is called horizontal range. The horizontal distance it's going to cover, it's called range or horizontal range. So now we are going to do some derivations in which we are going to understand what is H max, what is range, what are the formulas of these. Okay. Now let's understand, my dear friends, few small concepts. If you are projecting this ball, with some initial speed, or I should say, I should use velocity because it has direction also. Now we are talking about direction. With initial velocity, you are projecting this ball, making an angle theta, right? So we can take components of this velocity. Horizontal component is called u cos theta. I believe you are aware. And the vertical component is called u sine theta. Hope that's also very much clear to you. Right, guys? Now, what I mean to say that this u cos theta is not going to experience any gravity. It's not going to experience any gravitational force. Okay. So basically in the horizontal direction, there is no acceleration due to gravity. Only it's there in the vertical direction. Only in vertical. So if there is no acceleration in the horizontal direction, this horizontal component will remain same. That means it will remain u cos theta only. Always u cos theta. I believe that's correct. Right? So u cos theta will remain wherever throughout the motion, u cos theta will remain same. But u sin theta will keep on changing because acceleration due to gravity is acting in the vertical direction. Right? We generally, because of the sign convention, we generally consider upward motion to be positive and downward motion, downward direction negative. We can consider downward also to be positive and upward negative. It's up to you what you want to consider. Okay. Now, my dear friends, we are going to derive time of flight. How do we derive time of flight? Well, in BITSAT, no one is going to ask you this derivation of time of flight. First of all, please understand. But to clear your concept, because if your concepts are clear, you will be very quickly be able to solve this question. Now I tell you the trick and strategy how to think very quickly. Time of flight. When we are talking about time of flight, that means time for which this is going to be in this is going to be in this time for which this is going to be in air. That projectile motion is going to be in air. This projectile is going to be in air. That's called time of flight. So how to understand when you have kicked the ball and it comes back to ground, it means that initially the height was zero, and once again when it comes back the height is becoming zero. So time between zero height to once again zero height, it will be called time of flight. So what we can do? We can use equation of motion to derive time of flight. What we can do? Sy. That means if I do displacement in y direction zero once again, that means how much time it is taking to once again become to become the displacement zero, that we are going to understand, my dear friend. Sy equal to ut plus half a y direction into t. Now you can see this is a quadratic equation in t. That means you are going to get two values of t. You are going to get two values of t. That means, but is it possible? In this case, it is possible because one t1 is going to be that time when initial displacement in y direction was zero, and another time which you are going to get, it will be that time when once again the displacement is going to be zero. That is only we want. We want t2 because now it's going to take time to once again make displacement zero. That's the trick. Just make the just make the vertical direction. Just make the vertical direction zero. That's all, my dear friends. So what you can do, if I want to do, if I make sy equal to 0, I take t common. I take t common from here. What I do, I simply take t common from here. Okay. Once I take t common from here, I'm going to get basically what I'm going to get, my dear friends. I'm going to get what I'm going to do. Now understand? Just a minute. Some issue is coming in the video, but I'm going to help you. Don't worry. Okay. My video, I'm going to switch on my video once again. Some issue came, but it was a technical issue. Don't worry about it. Once you take t common, what is going to be left? Now, understand, I'm going to take ay as minus g because I am taking downward direction as negative and g is always downwards. Okay. And what about uy? I'm going to take uy as what ui I'm going to take? It is going to be plus u sine theta. Are you getting, my dear friend? Because it's in the y direction. What is the uy means? Velocity in y direction. That's what I want to do. So u sine theta minus half g t. Okay. So now you can understand that one t is anyway going to become zero, which you can ignore simply. T is coming out to be zero. You can simply ignore it because that's not going to be time of flight anyway. That's the initial time when displacement is zero. Now, other time which you are going to get is going to be 2u sine theta by g. Hopefully, it is clear, my dear friends. This is going to be your time of flight. Understood? Just make the vertical displacement zero. Is it fine? Second thing which you need to understand is what? Its range. And when I'm talking about range means horizontal distance. Now, horizontal distance is going to be simple, very easy. Horizontal distance, or I can say simply displacement. It's a horizontal displacement, I can say. Distance is also, I can say, because this here in this case, displacement and distance is going to be same. So horizontal distance, if I'm talking about horizontal distance, is going to be what, my dear friends? Can you understand what is going to be the horizontal distance in this case? Horizontal distance is going to be what? Horizontal distance is going to be simple. What you are going to do? You will take the horizontal velocity component, which is u cos theta, into time of flight, which we have just calculated, and the time of flight is 2u sine theta by g. So r comes out to be what? It comes out to be what, guys? U square 2 sine theta cos theta, and 2 sine theta cos theta is sine 2 theta by g. So here we got formula of range also. Horizontal distance is simple. Speed multiplied by time. And time is going to be time of flight. During the time of flight, how much horizontal distance it has traveled, that's going to be range, or I can say horizontal displacement also in this case. U square sin theta by g. H max means height maximum which it has reached. So now I can use formula Vy square equal to Uy square plus 2 plus 2 AS. Are you getting? Are you getting? Or I can write AY SY in vertical direction I'm going to apply. Now, when it reaches height maximum, what actually happens? Think about it. At height maximum, the vertical velocity will become zero. That time, only horizontal velocity will be there. Only horizontal velocity is going to be there, no vertical. Because if it has vertical velocity, it will go further. Hopefully, are you getting? It will further go up. Got a point or not, my dear friends? Now, if it will further go up, so in this case, we are only going to consider Vy final 0. Okay. So Vy final 0 is u square plus initial Uy is u sin theta square. Initial initial velocity in vertical direction is u sin theta plus 2. Ay you are going to put minus g because it's vertical downward and sy. So this is you are going to get sy. So my dear friends, what sy you are going to get? You are going to get u square sin square theta by 2g. This is your height maximum, my dear friends. This only is called, hopefully it is being clear to you, right? So when I'm talking about height maximum, we have got u square sin theta 2 theta by g. Range is u square sin theta by g. And time is 2u sin theta by g. Hopefully it is clear to you, right? Now we will do just simply one question and I will try to wind up this conceptual session. The question is, you have to find V when direction becomes perpendicular to initial velocity. What you have to find V when direction becomes, this is a very, very good question. It tests your concept. Find V when direction becomes perpendicular. When direction becomes perpendicular to initial velocity. Got a point? Many of the people, they don't even understand what is this question. Now try to understand this question. That means you are projecting a ball. You have projected a ball like this. Okay. This is initial velocity. At what is going to be the velocity when direction becomes perpendicular to initial velocity? This is the initial direction. Perpendicular to it can only be like this in this direction. Are you getting what I'm talking about? This is going to be perpendicular to this direction. That means this direction is perpendicular to initial direction. If initial angle is theta, this is going to be 90 minus theta. Are you getting? So with horizontal, when this ball comes here, with horizontal, it is making 90 minus theta. Are you getting? It is asking what is going to be this V. This V it is asking. What concept we are going to use, my dear friends, here? This is your x direction, this is your y direction. There is no acceleration due to gravity in x direction, so velocity component, horizontal velocity component will remain same. That means this u cos theta. This means this u cos theta will remain same everywhere. This is going to be u cos theta. Here also it is going to be u cos theta. So if I take the horizontal component of this v, that will also be equal to u cos theta. So v cos 90 minus theta is going to be equal to u cos theta. Are you getting what? Here I am using the concept that horizontal velocity doesn't change at all. It remains constant. Horizontal velocity remains constant. Now, v cos 90 minus theta is v sin theta equal to u cos theta. So v comes out to be what? U cos theta over sin theta. That comes out to be what? U cot theta. Isn't it easy, guys? Tell me seriously, isn't it easy? So easy. Just you need to be conceptual. That's all. Bits BitSat doesn't ask tough questions. It asks simple formula based or conceptual questions. You don't need to go much in depth. Where equation of trajectory is also there, but right now I am not taking that because it's going to take much time. Equation of trajectory. In the equation of trajectory, what I tell you, what you have to do, you have to just simply eliminate the time term. It is the equation of this path in x and y. So you can write equation in x, equation in y, and try eliminate time. In equation of trajectory, your time term should not come at all. So if you get a question which of the following is not an equation of trajectory, just take that answer where you see time term. Are you getting? So these conceptual clarity should be there. Tips and strategy must be used. So what we have done, we have understood what is projectile motion. It is motion under gravity. It's not necessarily it's not necessarily a parabolic motion. Then we understood time of flight, range, h max. Hopefully you have understood these formulas. You must mug up h max, range, and time of flight, and conceptual clarity must be there. So my dear friend, hopefully you have understood, and in the next session we will meet with another important topic, and then you should keep practicing, and see you in the next session. Take care. Bye bye.